Right, apologies for anyone that joined me live a little while ago and it didn't really work. So let's start again. We're looking at mechanics and we're looking at what we're going to be looking at today is the first chapter of A-level mechanics. Well, there's an intro chapter, it's the chapter after that. So if you're doing Edexcel, I think it comes up as chapter 9 in your textbook because they have all the statistics first. But it's revision essentially from GCSE, and the questions are just a little bit trickier. So what you already, or the knowledge you should already have is you should already recognize a distance time graph. Now in mechanics, let's just make sure we have our letters correct. I'm going to use S, which is going to represent the displacement. Now it's really key to understand the difference between displacement and distance. So if I have me here, and we go for a walk, we walk around the houses, we go on our hours, quarantine walk, and we come back home. And I'm coming back to the exact same point I started. I might have walked 2 kilometers, but actually my displacement is 0. So your displacement represents the difference from where I started and to where I ended. So that's S represents displacement. We measure it in meters. And we have T, which will represent time, which is measured in seconds. So that is your starting point. And then we're going to think about a distance time graph. So if I have a cyclist, so they ride in a straight line. So a cyclist rides in a straight line for 20 minutes. Okay, she waits half an hour. Then returns to her starting point, then returns in 15 minutes. And we want to draw a displacement time graph or a distance time graph. So this is nothing new from what you've done at GCSE. So you'll have time, which is going to be represented, we're doing this one in minutes, okay, because that's what we're given, and we're given our distance. She drives 20 minutes, so let's say she tries a straight line for 20 minutes and she travels 5 kilometers. So we've got 5 kilometers. That takes 20 minutes. So we've got a constant acceleration. So we've got a straight line, so we're representing the constant acceleration. And then she waits for half an hour. So that's 30 minutes she's waiting for. So that takes me to 50 minutes. And in that 30 minutes, she's staying at 5 kilometers. She's not moved. And then she returns back. And that takes her 15 minutes, so she goes to 65. Okay, so if I wanted to work out, I can use this graph to work out a few different things. So we can work out the average. So this is my distance in kilometers. Right. So I've got to think about what I can calculate. So if I have a look at this, I can work out distance over time, which will give me my velocity in that first bit. And distance divided by time is essentially going to be a gradient. So the gradient of your distance time graph gives you the velocity. So this line here is going to give me my velocity. So we'll have distance divided by time. So the distance is 5. And remember, we're going to do distance, and I'm going to work it out. If I wanted it kilometers per minute, I'd do 5 over 20. But say the question said they wanted your velocity in kilometers per hour. It's much easier to change your units at this point before you put it into your calculator. So we're going to have 5 divided by 20, which is 1/3 of an hour. So we've got distance or displacement over time. And when I plug that in, I'm going to get 15, and it's 15 kilometers per hour. So the gradient here is 15 kilometers per hour. And so now if I wanted to work out the average velocity for the whole journey, well, we can see that's 15. This bit is 0 kilometers per hour. And then going down, well, we say, well, it's a negative velocity because it's going in the opposite direction from where I was going before. The displacement is 5. So your displacement divided by your time. So your displacement in this case is 5. Your time is 15 minutes, which is 1/4 of an hour. So we're going to get, and I've got -5 because we're going in the other direction, kilometers per hour. So that's going to give me -20 kilometers. So kilometers per hour. Okay, so now if I wanted to have my average velocity, it's going to be my total distance divided by my total time. So what's my total distance traveled? So I'm not looking for the average velocity. If I'm looking for the average speed, I'm going to find the total distance, which in this case will be, well, she travels 5 up and 5 down. So my average speed would be 10 divided by however much time it is, 1 hour, 1 5/60. If I wanted the velocity, the 20, -20 and the 15, you'd end up with -5 when you sum them up. So you've got to think what the question's asking. So that's just to give you an intro. I don't worry too much about it, but those are your distance time graphs, which you may have come across before. But what a lot of your exams are going to be, and the kind of questions that you'll have, will tend to be velocity time graphs. So we've got time and we've got velocity. Right, so what's velocity representing? Velocity is representing, it's your speed, but it has a direction. So if you have a straight line, then your velocity is not changing. So if I have a straight line like this, it doesn't mean it's not moving, it means I've got constant velocity, right? So whatever value that is, it means it's moving, but it's not getting faster, it's not getting slower, it's staying the same. If it wasn't moving at all and it was stationary, that line would have to be on the axis, so it would have to be at 0. But because it's above, we've got some constant velocity. Whenever we have a graph with a gradient, so let's take a positive gradient. So we've got something like this. Then this is going to give us constant acceleration. So we've got constant acceleration, constant velocity, and constant acceleration. So the velocity here is increasing over time. The gradient of this graph, so the gradient will give you the acceleration. So none of this should be new. All right, so you've got constant acceleration and the gradient gives you the acceleration. So you can also, if you have a velocity time graph, what else does it tell you? So let's find a graph with some numbers and let's see what it tells us. So the gradient gives you the acceleration over that period of time. The area under gives you the distance traveled. So if I draw a velocity time graph, so let's put everything in the correct units. Velocity should be in meters per second. And say we typically get something that looks like this. So this is my velocity time graph. Now let's say they're moving on a straight road. Say this is 10 seconds. And for the first 10 seconds, they're moving at a constant speed or constant velocity of 6. and then they decelerate at a constant rate for 3 seconds. So this takes us to 13 here. Right. If I look at that, I can figure out the area under that curve. Now we can do it 2 ways. We can use the trapezium rule, which is a lot easier to find it, not the trapezium rule, sorry, the area for trapezium, which is a lot easier, and we can do it in one go. So half the sum of the parallel sides times the distance between them. So if we have a look, what are our parallel sides? We've got this side here, which is 13. We've got this side here, which is 10. And we've got the distance between them, which is 6. So the area here would be 13 plus 10 over 2 multiplied by 6. So that gives us 23 divided by 2 times 6. So that would give us 69. And so the distance traveled would be 69 meters. Now, of course, you could have done it by doing a triangle and a rectangle, but the area under the velocity time graph is the distance traveled. So the area under the velocity time graph is your distance traveled. Right. So now what about if I wanted to find how quickly the cyclist decelerated? So we're looking for the gradient. So the gradient is going to give me the deceleration. So I want the gradient of this bit here. So I've got my change in y, which is going from 6 to 0. So I've got -6. My change in x, which was 3. So my gradient is going to be -6 over 3, so -2. But because we're asked for the deceleration, we don't need the minus there because it's got the D in the word. So we'd say the deceleration is 2 meters per second squared, which is your units for acceleration. So hopefully a lot of this is not new, you recognize this, but let's have a look at something with maybe just letters in it and work out how we can then move on from there. So say we have a particle. So we've got a particle that moves along a straight line. So a particle moves along a straight line. It accelerates from rest to 8 meters per second in t seconds, okay? And then it moves at a constant speed for 5t seconds. For 5t seconds, and that's before it then decelerates to rest. Before decelerating to rest. To rest over 40 seconds. Right, now we want to draw that. So let's say we want to draw a velocity time graph. So we've got our axes, time always on my x-axis, velocity on my y-axis, meters per second. So we're starting from rest. We see the word rest, and that means we're starting at 0. So we're going from 0 meters per second to 8. So we're going from 0 until 8. So we're going 0 to 8, and that takes us t seconds. And then we've got a constant speed. Now remember, the constant speed was the straight line. So you're not accelerating, your velocity is not changing, you're just moving in a straight line. So you're moving in a straight line, and that space here is 5t seconds. And then you're decelerating. And that space here is 40 seconds. Right. And that would be your graph. Now let's say they tell you the area by telling you what the distance is. So they say the particle has traveled. So the particle has traveled 600 meters. Find t. So now that tells us that the area under the graph is t. Now remember the area of a trapezium, we've got half, or a plus b, times h. So we're going to have half our a, so this distance here, which is 5t, plus this entire distance here, which is 6t plus 40. And then the distance between it is 8. So and we know that all of this equals 600. So then we're going to solve that. So we can do 600 divided by 8 times 2, move everything to one side, so we get 150. 6 plus 5 gives us 11t plus 40. So 11t equals 150 minus 40, so 110. Divide that by 11, we're left with t must be 10. And you've solved the question. So hopefully that's nothing too new. Now in physics, what you will have come across already is the idea of SUVAT. Now, if you haven't, it's not a problem. We're going to go through them. So SUVAT is just it's not even an acronym. I think that's what they're called, aren't they? And you have a list of letters. Anyway, so it's an acronym for those letters. And you need to remember this because you're always going to just write them down. So SUVAT. Now let's think what each of them means. We already talked about S, and we talked about how this is the displacement. And I'm going to put in brackets distance so you remember what we were referring to. And that's in meters. U is my starting or my initial velocity. And that's in meters per second, generally. And this is going to be my final velocity, also in meters per second. A is my acceleration. It would be useful if I could spell. Which is in meters per second squared. And t is in time, which we measure in seconds. So that's SUVAT. So you need to know what each of those letters mean, and we're going to carry them forward in all the questions we do. So now you already know what acceleration is. Acceleration is your change in speed, and in this case, velocity, over time. So we know that acceleration is my change in speed. So that must be my final velocity minus my starting velocity over the time. So A equals V minus U over T. And when we rearrange that to make V the subject, we get U plus AT. Now, what you get in A-level maths is you will get all your formulas. So we're going to start with 2 of them. So we've got acceleration here. And then remember we talked about the distance under a graph. So if we think about it, the distance, let's talk about the distance moved and the distance under a graph. So distance moved is going to be your average speed over time. So remember your average or your mean, your middle is V plus U over 2 times time. And then we know the area under the graph we said was represented by a trapezium. And let's actually do that as a separate proof. So if we have a look, if I give you a graph, let's take, let's say our initial velocity is here. I'm going to call that U. And then I go up to here, and that's going to be V. So this is my T, my time versus velocity graph. Right. So we want the area under this graph. This bit's going to be T. This space here is going to be u, and this space here, this bit here is v. Now, if I want to work the area of that out, I take the area under the graph, so the area of my trapezium is a half a plus b times h. In this case, my a and b, so my parallel sides are u and v. So I get a half u plus v times t, and that's what we just looked at as well. So that is the area under my graph, which will be my distance. That's another way to think about it. So here are two formulas. So we're going to start off with just those two formulas and go with a strategy with how we use these formulas, or how we use SUVAT to calculate different things. So what we do here is when we use SUVAT, is the first thing we're going to do is let's look at the question. Right, so if we've got a cyclist is traveling along a straight road. So actually, I think I put them, I'm going to try share them again. This crashed last time I tried to do this, but hopefully this works. Right. You've got a cyclist is traveling along a straight road. She accelerates at a constant rate from a speed of 4 to a speed of 7.5 in 40 seconds. You're going to find the distance traveled over this 40 seconds. So what we're going to do is the first step is we're going to write that SUVAT out. Right, and we're going to think what's happening. So she's going from a speed of 4, so that she's starting at 4. So that tells you u must be 4. Oh God, I've written u again. It's 4. To a speed of 7.5. So v is going to be 7.5. And that's taking 40 seconds. And what you need to find is your distance traveled. So we want to know what this is. Now remember the formulas we've just looked at, v equals u plus at, and s equals u plus v over 2 times t. And remember, you're given these. So you have these near you. So you're like, which of these formulas will work? So you look at the formulas, you want to find s, we're going to use the second formula, you plug in the numbers. So s equals 4 plus 7.5 over 2 times by 40, which gives us 230 meters. The next bit of the question says, find the acceleration. So now we're like, okay, well now we want to find the A. Now what I wouldn't do, even though you found your S, you know this is 230, we're going to try not use it if we can help it, just in case you've calculated it wrong. So try to use the numbers only in the question, unless you have to use your answer from the previous bit. So the acceleration traveled, so we've got v equals u plus at. We plug in the numbers we know. We know v is 7.5. We know u is 4. We don't know a, and we know t is 40. So we get 40t. And when you 40a, so we know t, we don't know a. Clearly it's too late for me today. So the acceleration, we rearrange that. We get 0.0875 meters per second squared. So that's one example of what we might use. Right, let's take another one. So if we take the next one, we've got a particle moves in a straight line from A to B with a constant deceleration of 1.5. The speed of the particle at A is 8, and at B, it's 2. Find the time taken for the particle to go from A to B. So what we're going to do is the same thing, but in this case, and actually to get into the habit of it for trickier questions, it might be worth just drawing a diagram. So we're going from A, where we're at 8 meters per second, to be where we're now at 2 meters per second. And we're going to say, we're going to write SUVAT out again, S-U-V-A-T. Right, and we're going to go, what's my S, what's my U, what's my V, what's my A, what's my T? What do I know? I don't know S, so that's a question mark. I know that U is 8. I know that V is 2. I know that A is a deceleration. So C, deceleration, it's minus 1.5. And I want to find out T. So I look to my formulas and I say which one makes sense. So looking at those formulas, you can see that we can use V equals U plus AT. We're going to plug in the numbers. 2 equals 8 minus 1.5 T. Rearrange that, and we get T equals 4. Now you've got to make sure the T makes sense. You can't have a negative time. So in this case, T is 4, that makes perfect sense, and we're okay here. Now let's think about the distance. So again, even though we have found out our T, we don't necessarily need to use it. So if I want to find my distance from A to B, what am I going to do? So if I have a look, I'm going to have my distance from A to B. I'm going to use the other formula. So S equals U plus V over 2 times T. I'm going to sub in my values. 8 plus 2 over T. 8 plus 2 over 2 times 4. And I'm going to get 20 meters. So that's using the first 2 types of formulas that you have there. So the next set of let's just make sure this is on the whiteboard. Okay. Sorry, it's decided to freeze my whiteboard. So the next step of formulas that we're going to look at, we're going to attempt to do this again in a second, is there's some other SUVAT formulas that are given. Now you don't necessarily need to know the proof, but all the proofs come from these 2 main formulas. So I'm going to go through them just because I think they're interesting, but you don't necessarily need to learn these. So let's try again and hopefully this works. So let's take our formula that we know. We know V equals U plus AT. If I take away U from both sides, I get V minus U equals AT. If I then divide by A, I've got V minus U over A equals T. Now I know that S is the same as U plus V to T. But instead of the T, I'm going to substitute all of this for this. So when I substitute it in, I get S equals U plus V over 2 multiplied by V minus U over A. Now, hopefully you recognize the top bits of that is a difference of 2 squares. So the top parts of that equation are simply V plus U multiplied by V minus U. And when you plug that in, you're going to get V. So you can write that, even though it says U plus V, if you've written it V plus U, it's the same thing. So you've got V squared minus U squared. On the bottom, you've got 2 times A, so you've got 2A. So now we can multiply that A to the other side to get 2AS equals V squared minus U squared. So we get V squared equals U squared plus 2AS. And that is another one of our SUVAT equations, which is going to be added to it, to our thing. So now let's take the next one. So we can take our formula we already know, U plus V over 2 multiplied by T. Now I also know that V equals U plus AT. So I can substitute, that becomes algebra, all of this into there. So I end up with S equals U plus AT over 2 times by T. So I get S equals 2U plus AT over 2 times by T. So I end up with S equals, the 2's cancel there and leave me with U plus a half AT times by T. So S equals UT plus a half AT squared. And there's a few more which, if you look at, you'll be able to see exactly where they come from. So there's one with velocity, which comes as one more actually, that comes in the same place. So you end up with these 5 equations. Like I said, these are all given to you in the formula book. So you don't need to learn them, but by the time you've done this chapter, you probably will have used them so many times that you'll know them. Okay, so now we're going to use these and actually look at some questions. And you've got to say, what do I know and what do I need? So they all start in exactly the same way. So we've got a particle moving in a straight line from A to B with constant acceleration of 5 meters per second. So you're told in the question, it's going from A to B. The acceleration is 5 meters per second. They're saying at A, velocity is 3 meters per second. And at B, velocity is 18 meters per second. And what we're going to do is find the distance from A to B, or find out what we can from this information. So we're starting at A, and at A we're at 3 meters per second. We're going to B, and we're at 18 meters per second here. And we're going to write SUVAT. All right, so S is what we want to know. Our A is 3, our V is 18, our A is 5. Sorry, our U is 3, our V is 18, and our A is 5. And we're trying to find our S. So we're not concerned with the T. So we're looking at which one of these doesn't have a T. That's actually the easiest one. So when you don't know T, there's only one equation that doesn't have a T in it. And that's V squared equals U squared plus 2AS. And so what you're going to do is substitute that in. And we're going to get 18 squared equals 3 squared plus 2 times 5 times S. And when we rearrange that, we've got 18 squared minus 3 squared equals 10S. So S is going to be the same as 18 squared minus 3 squared over 10. And you can put that all into your calculator in one go, so you don't risk having numbers in the whole time. Let's try use another one of these formulas. So let's do one more of these. We take, right, so just so I've got the formulas on the side, I'm just going to rub this out instead of rewriting them. So what you've got here is you've got a particle and it's moving in a straight horizontal line with constant deceleration of 4 meters per second. I'm just reading out the exam question. At time t equals 0, the particle passes through point O with a speed of 13, traveling where OA is 20. So we've got, you've got a particle is moving on a straight horizontal line with a constant deceleration of 4 meters per second. So at time t equals 0, it's at 13 meters per second, and it's traveling from O to A, which is 20 meters apart. And we want to find the time that the particle passes through A. So we've got O. Okay, my computer. All right, so we've got O and we've got A. My computer's freezing. If this cuts out, which it did a few nights ago, I apologize profusely. I will record this properly and I will upload it later. It's the YouTube link has been a bit temperamental. So if that happens, I apologize. I will re-record this and we will go through it, but it might freeze and die on me. Right, so let's see what we know. So it goes from O to A, and when it's going past, it can go past A, and we don't know what happens when it goes past A. So let's think of SUVAT. S in this case is 20. U is 13, because that's my initial speed. I don't know what V is. I'm told it's decelerating. So it's decelerating, and that's -4. And I want to find out what T is as well. So we're like, we don't need the V, but we want to find out the T, and we have everything else. So we look over to our equations, and we see that the equation that we probably need to use is this one over here. So we get S equals UT plus 1/2 AT squared. S is 20. We get 13T plus 1/2, our A was -4, T squared. Now, do you notice the squared? It means we're going to end up with a quadratic. So we're going to clean that up, and the quadratic we get is 2T squared minus 13T plus 20. You can plug that into your calculator, or you can factorize it. 2T minus 5, T minus 4, and you get T equals 2.5 or 4. Now, how can we have two T's? It's going in a straight line. What we've noticed is the acceleration is negative. So what it's telling you is the particle passes A, and then it changes direction, and it passes A again. So the first time that it passes A is 2.5, and the second time it passes A is 4. So the difference, or the time that it was beyond A, would be 1.5 seconds. Right, so this is totally freezing out on me. Hopefully it's a bit intermittent, and I'm not sure whether that's reflecting. So I'm going to stop the stream. I am going to record this again, and I will record a mechanics lesson properly, where hopefully the PowerPoint works and everything works. I don't have to keep writing equations out. But anybody that has been watching, I hope this is useful a little bit, and I will upload and I will redo this. But at 8:30 tomorrow, we will finish off. So I'll sort of start where my recording hopefully ends, with all the equations up and how we use them. And we'll just do a whole load of examples.